Okay, I'm just going to briefly talk about this answer because many students have actually asked me about 2012 paper 3 question 2b. B part 1, where solution of I minus and Fe3 plus are mixed and the equilibrium is set up, write a balance equation for this equilibrium. Okay, I believe that you'll be able to calculate E naught cell, which is positive, because if you go and check data booklet, I minus can only be oxidized. Okay, I minus can only be oxidized. Okay, I minus oxidized I2. And therefore, for a redox to occur, Fe3 plus must be reduced. Okay, and it's reduced to Fe2 plus 0. E naught reduction is E naught positive 0.77. E naught oxidation of I minus to I2 is negative 0.54. So I believe that you can calculate E naught cell is positive. And once you know that E naught cell is positive, the reaction is energetically feasible. And therefore, it's a full forward arrow. Please take note. Once E naught cell is negative, I repeat, reaction is energetically feasible. It's a full forward arrow. Okay, so this is the balance equation. Part 2. Use the data booklet to suggest how the position of equilibrium between I minus and Fe3 plus would change in the presence of cyanide ligands. So I just want to point out that you need to understand that this is the presence of cyanide ligand. This part is the key part. Okay, so the reason why I wrote this equation out is that you must understand that although they say Fe3 plus equals, okay, you go and check data booklet, this equilibrium is what you're, this is the one you're looking at, the positive 0.77. Even though state symbols are not stated, you should know that Fe3 plus should be in the aqueous state. The ions not stated, the state symbol is in the aqueous state. Fe2 plus, state symbol not given, is also in the aqueous state. So, what is happening is that we are really talking about this equilibrium at first, when we're talking about Fe3 plus equals. But now with the presence of cyanide, okay, the key thing is that the cyanide ligands will undergo ligand exchange. Okay, it will undergo ligand exchange. And they will substitute the water ligands of both of these ions that I've just circled. Okay? Okay, so I want you to pay attention to this one. So instead of Fe3 plus equals in equilibrium with Fe2 plus equals, now the water ligands are kicked out with cyanide, and this is the equilibrium we're talking about. FeCN6 3 minus, okay, is being reduced to give us FeCN6 4 minus. Okay, so this is the E naught we're going to talk about is now this one, FeCN6 3 minus is reduced to FeCN6 4 minus. So it is actually positive 0.36. Okay? Positive 0.36. Okay, this E naught reduction is now positive 0.36 volts. Okay, and this less positive value, what does it tell us? Because at first, when the ligands are water, okay, to reduce plus 3 iron to plus 2 iron, the E naught reduction is positive 0.77. Now, if I want to reduce, because this iron is still plus 3 minus 6 is minus 3, right? That's the overall charge. This iron is still plus 2 oxidation state. So I am still now reducing from plus 3 to plus 2 iron. But now this iron ions are complex with cyanide ligands. And this value is less positive. Okay? What does a less positive value tell us? Okay, a less positive value tells us that it is harder to reduce this FeCN6 3 minus to FeCN6 4 minus. Sorry, it is harder to reduce FeCN6 3 minus to FeCN6 4 minus. Okay, still a reduction from plus 3 to plus 2, but now with the ligands being cyanide, it is harder to do so. Okay, it's harder to reduce this ion here, FeCN6 3 minus, meaning that this ion here, FeCN6 3 minus, is less easily reduced, therefore it's a weaker oxidizing agent. I repeat, I am really talking about this ion here. FeCN6 3 minus is actually a weaker oxidizing agent. Okay? And if you check the E naught cell, you will realize that, okay, to reduce the FeCN6 3 minus to the plus 2 oxidation state, E naught reduction is positive 0.36. Plus the E naught oxidation, it is still negative 0.54. And you will find that this value is negative 0.18. And this value is negative. That means the reaction is energetically not feasible between your the Fe3 plus complex with cyanide and I minus, correct? And this is what the question is trying to say. They are asking you how the position of equilibrium, the overall equilibrium between I minus and Fe3 plus, how is the equilibrium position like? And since E naught cell is negative, right? E naught cell, that means the equilibrium lies on the left. I've changed the answer slightly. The equilibrium lies on the left, okay, towards the reactant side, towards FeCN6 minus as well as I minus, meaning that the reaction is not feasible energetically. Okay, and this is caused by the reduction in the oxidizing power of the Fe3 ions complex with cyanide. Okay, that means they're talking about this one, FeCN6 minus. Okay, so instead of LCP, I cancelled it, and you just have to say that the overall position of equilibrium that is between the I minus Fe3 plus lies on the left, meaning that it's all reactants, no products, because E naught cell is negative, not feasible. Reaction is not energetically feasible. That is the meaning of equilibrium lies on the left. And if you look at the answer, this is what they're trying to say. Okay, equilibrium lies on the left because it's all reactants, all I minus, or FeCN6 minus, the cyanide complex, iron 3 plus. Okay, but but this is lying on the left. Yes, and it's caused by the reduction in oxidizing power. Okay, do not talk about this one is wrong. This one is wrong. Okay, because the cyanide will react with both the Fe3 plus as well as Fe2 plus equals to kick out all the water. Okay, so in this case, I've changed the answer. Please take note of the change in green.